the market share by BMS in terms of application by 2018. Here, automotive consumer electronics plays a huge role in the battery market, BMS market, and then parallelly the medical field, military field, renewable energy system, UPS, telecommunication, and other field also are increase their market share in BMS because they are using a battery maximum time, and so they want to protect the battery and prolong its lifetime. Next. So, why we need BMS? We need BMS to protect the battery. So, BMS does the protection in the battery from above the following areas, where the cell protection, current and voltage protection, thermal management, intelligent cell balancing, state of heat monitoring, and state of surge monitoring. We'll discuss about the points briefly on our next subsequent slides. Next. So, here the basic framework of battery management system. What actually BMS do in a battery? Actually, BMS works in two ways, hardware and software. In hardware part, that is a sensor system. It is a device that detects and responds to some type of input from the physical environment. The output is generally a signal that is converted to human readable display at the sensor location for reading or further processes. In BMS, it is used to sense the parameter voltage, current, and temperature. Next is safety circuitry. As electronic circuit, an electronic circuit that prevents malfunction by sounding an alert or activating a trip circuit on a protective device. It is required in BMS to accurately control the alarms to prevent the battery from overheating, oversurge, and overdischarge. Next is surge control. A surge control or surge regulator limits the rate at which electric current is added to or drawn from electric batteries. It is also prevent from overcharging and overheating, and which can reduce battery performance or lifespan and pose a safety risk. As the batteries are charged by constant voltage or constant current method, a potentiostat are required to balance the battery cells. Next is thermal management. It is the ability to control the temperature of a system by means of a technologically based on thermodynamics and heat transfer. It can be either active or maybe passive, and the cooling medium can either be air, liquid, or some form of phase change. Since the temperature difference among the cells has an effect on cell performance, reliability, and in same imbalance, so a thermal management system is placed inside the BMS. Air cooling is advantageable because of its simplicity. Such system can be passive, relying only on the connection of the surrounding air, or active, utilizing fans for airflow. Liquid cooling has a natural cooling potential than air cooling, as liquid coolants have higher thermal than air. The battery can either be directly in the coolant, or coolant can flow through the BMS contact the battery. Communication. One final BMS function is the need in communication with additional vehicle controller. BMS often requires changes in condition and can provide some forecasting of battery pack capability in the near future. Data transfer throughout the BMS is required since BMS module operates in stand-alone mode. In order to communicate data within the BMS, a control transmitter is required. As an example, to communicate between a battery and charger, or battery and a user. So next is the way software. The software is considered as the center of BMS, as it controls the operation of hardware and make decisions and estimates state for all the sensors. It also performs the data analysis for continuously controlling and updating battery functions, which determines fault identification and state estimation. Battery parameters. Detection of battery parameters includes individual cell voltage measurement, that is to prevent oversurge and overdischarge. Then next, total cell voltage, total current, impedance detection, temperature detection. Because why we need battery parameters? Because without knowing the battery parameters of a battery, we can't know the different states of the battery. So next is battery states. Battery states estimations contain SOC, that is state of charge, and SOH, that is state of health, which can set the working condition based on various model and algorithms. The SOC is estimated using voltage, current, and temperature, and SOH is estimated according to the perfect performance degradation in battery, which is relatable to its capacity fit and its power fit. Next is cell balancing. Battery cell balancing is need to get the better performance without causing any surging or over discharging. The objective of cell balancing is to make the value of SOC among cells as close as possible. Analysis. In order to identifying the abnormalities in a battery and fault analysis, an intelligent data control system is required, where historical data to be stored which are already experimented and verified, and then an alarm signal to be provided before any fault occurs in the battery. Next is user interface. The user will get all the necessary information through a user interface, which will show on the display of BMS. Depending on the value of the SOC, the available driving range will be displayed on the dashboard. So overall, this is the framework of the BMS. Next. So this is the block diagram of the battery management system. It consists of battery packs that has a numerous number of cells is in it that makes it a battery pack. The main function of a BMS is it measures current, voltage, and temperature and controls cooling, balancing, power limits, as well as operator to the different markers for startup and power up. Next is it continuously monitors all the parameters in and out of the battery pack to ensure it is being operated in a safe condition and in the entire time. All the values of temperature, current, and voltage to the measurement, as we see all the values of temperature, current, and voltage goes to the measurement, where the following parameters are measured. That is capability estimation. One of the measurement parameter is the capability estimation, where the battery cell total capacity refers to the total amount of charge that can be extracted from a fully charged cell. So BMS helps to calculate the maximum energy storage capability of a battery pack, the remaining energy in a battery pack. Next measurement is SOC, that is state of charge. That parameter it determines the level of charge of an electric battery and to its capacity. Then next is state of health. It reflects the ability of a battery to deliver and receive of energy and power. Typically, a battery's SOH will be 100% at the time of manufacture and will decrease over time and use. Next is cell balancing. As already I said, it is need to get the better performance without causing any overcharging or over discharging. Next is discharger. A BMS has a discharger. It works when a cell drains to certain voltage. The protector will cut off the discharge by opening the discharger. Next is CAN bus controller, which means controller area network bus, is heavily used in electrical vehicle applications. The CAN bus controller allows the system to detect whether the battery is overloaded through the CAN nodes and disable non-safely critical devices when the battery is overloaded to protect the battery and prolong the life of the battery. Next. So here the general system structure of the BMS system. So here in the as we see in the measurements of temperature, current, and voltage goes to the analog processor, and where the analog signal is converted to the digital signal by a analog to digital converter. Next, the converted values of voltage, temperature, and current is go to the microprocessor for calibration with the RAM and ROM, where already the data are stored, reference data as, and after the calibration in the display, the will show what is the state of charge of the battery and above the and different states of the battery, like of its charge, how much remaining standby time, and how much time to fully charge the battery. Next. So basically we use the lithium-ion battery in our project because lithium-ion is the lightest metal and greatest electrochemical potential, has the greatest electrochemical potential. Next, it has highest energy density, which means we can store a maximum amount of energy in a small area. It requires less maintenance than the other batteries. It requires no schedule cycling, and its self-discharge is less than nickel methyl hydride batteries and the lead batteries. So we use the lithium-ion batteries. Next. So it has also some drawbacks also. The drawbacks of lithium-ion is lithium ions are brittle. So it requires a protection circuit to maintain a safe operation. They need protection circuits from being overcharged and discharged quickly. Life of a lithium battery depends on the surrounding like temperature as well as charge discharge cycle. So its lifespan is less, and it is expensive to manufacture. And its metals and chemicals which are used in this battery are changing on the counting basic on continuous basis. Like when we are using the conditions of the lithium ion will be changed frequently. So the next slide is battery challenges, which will be presented by Ganesh Das. Thank you.
Good morning to all the teachers. As my fellow mate Suraj has already mentioned about the drawbacks about the lithium ions which are being widely used. These lithium ions are very sensitive to the operation outside their recommended operating area, as we can see from the diagram, which could lead to shortened lifetime of the battery. It can damage it, and it has a explosion risk. So in the diagram, as we can see that the green area, it depicts that safety operating area. So if a lithium ion battery is operated beyond this region, then it may get it will have a risk of damaging. So the dangerous area is that area in which the lithium ion cannot operate. And it has two graphs. One is for voltage and another is for the current volt. So the next slide. So as we can see on the screen that it is a battery data comparison table of state of charge, which has been calculated by doing many researches in the society where this battery is being widely used. So whenever we are working with a particular battery, like for example a lithium ion battery, we can compare our output results with the given data of the table. So it is an universal research data which we have put here. So we can go to the next slide now. So in the next slide, it is a statistical graph of battery life in terms of temperature of real cranking battery and slow discharge battery. So the real cranking battery are those batteries in which are also known as starter batteries, which are only used to start up the machine. It is characterized by having a greater starting power. So this type of batteries are used in submarines or cars that are resided in very cold places. And the next is the slow discharge battery. So slow discharge battery, as its name implies, it discharges slowly, allowing it to provide stable energy for a long period of time. It has a much longer service than a starter battery. It can be used in boats, tractors, etc. So in the graph, it shows in the first graph, we can see that it is for a fresh battery. So here we can see that an RC battery is given with in basis of temperature and its battery life. So in the first graph, we can see that when a 100% RC battery is started in 0-degree temperature, it shows a 100% battery life. But as the temperature keeps on rising, the battery life decreases. So we can say that it is same for the SD battery also. SD battery also, for when it gets started, its battery life is near to 90 degree. So in the next slide, we can see that when a battery is being used for like 1 year, we can say that it starts to get a decline in its as the temperature rises, the battery life decreases. So what happens that in one life of use, the expected battery life is deteriorated in a period of time. So it is observed from the graph that battery life is reducing with increasing temperature. We can see in the next slide. We can see in the next slide of a 2-year-old battery. So in 2 years, when a battery is being run for 2 years, it starts to show some inaccuracy. So an inaccuracy and like for a sudden increase in charge. So we can say that battery is degrading as it is being old, and its life is also reducing as the temperature is increasing rapidly. So these are the graphs that shows the temperature and the expected battery life of a fresh battery, of a 1-year-old battery and a 2-year-old battery. So in the next slide, we can see BMS topology. So BMS topology, BMS topology is by the way which we can design a BMS. So there are mainly 3 ways by which a BMS can be designed. Number 1 is the distributed. In the distributed topology, a BMS board is installed in each cell with just a single communication cable. As we can see in the diagram, the blue line is a single communication cable between the battery and a controller. So it is mostly used in electric vehicles. For data communication from the cell, it uses a RS485 3-wire connection. Multiple receivers can be connected in such a network. So in distributed BMS are most expensive in use. It is simplest to install and it offers the most cleanest assembly. So the next is the modular topology. In modular topology, we can see there are a few controllers, each handling a certain number of cells with communication between the controller. A 4-wire connection is used in this connection. In this topology, the cell forms a few groups which are connected to each slave, which import the data to a master. Modular BMS offers a compromise to the features and problems of other 2 topologies. It is mostly used in automotive, railways, industrial and consumer uses, etc. So the last type of topology that we can use is the next page is a centralized topology. In centralized BMS topology, a single controller is connected to the battery cells through a multitude of wires. Centralized BMS are most economical, least expandable, and are plagued by a multitude of wires. As we can see here, it can be used for battery energy storage system. Now to the next slide. These are the areas of protection which a BMS system provides. Number 1 is the overcurrent protection. During the charging point, it provides a cell. It protects the cell from overcurrent so that the cell doesn't get damaged. Number 2 is the overvoltage, especially important for lead acid battery and lithium-ion batteries. As we all know that lead acid battery and lithium-ion batteries are very fragile and they need complete care and protection. So due to overvoltage during the charging period, this may affect the battery, and if a battery is affected, then the whole battery pack will get damaged and the BMS needs to be replaced. So this is one of the area of protection. Next is the undervoltage protection. So undervoltage will also lead to various problems in a BMS. Next is the over temperature. So if a BMS runs for a particular period of time, eventually it will rise in temperature, and this temperature rise will lead to the failure of the battery cells. And for this reason, the BMS creates a protection circuit from protecting the cells from over temperature and under temperature, as well as it goes for over pressure. So my next slide will be explained by my fellow mate Mayuri Soikia.
Hello, Manoj speaking. Ganeshwari, can you go to slide number 9?
Slide number 9. Okay, sir. Yes, sir.
So this current and voltage, especially this current that you are talking of in the right hand graph, right?
Yes, sir.
So this current is which current? The current by which the battery is getting charged, or the current
Sir.
that the battery is being discharged?
Sir, every cell, lithium cell has a limited current capacity,
Capa-
charge current.
Capability, right? So is this
Cannot operate.
capability, huh?
Yes, sir.
So is this capability what you are talking of? Is it
Yes,
the
sir.
accepting capability or delivering capability?
Sir, accepting capability. When the lithium-ion battery is charged.
Okay. Accepting capability.
Yes, sir.
Okay. So you continue with the other speaker who will speak.
Okay, thank you, sir.
Hmm.
So good morning to good morning to everyone and my respected teachers. So here this slide is about the need for BMS. That means why we use the BMS. So of course there are some purpose that we use the BMS in battery cell. So first one is the cell protection. So what is cell protection? In a battery pack, there are lots of cells. There are numerous cells. It can be 6, 5 to numerous 1,000 cells. So every cell need to be protected because every hello, anyone tell something? Hello.
Be planning, okay?
We can hear you. Yeah.
Okay, just wait. Rahim sir will call you.
May,
Okay,
may I continue?
you will explain. Okay, just wait. Let Aranyak to explain. Okay, maybe just wait. Rasmi sir will call you.
Yeah, Mayuri, if your earphone is not working, just remove your earphone and just you can speak it that way also, I think.
Sir, her connection has been she has been disconnected, so she is asking to connect again. So,
Okay, let her do that. Okay. In between, you continue now.
Okay, sir. May I continue?
Yeah, Aryan, continue.
Okay. So self protection is a major reason for why we use the BMS. So the BMS is protect the cell, like it protect the excessive current and during the charging or discharging, or like short circuit over voltage or overcharging under voltage. So the next slide is about Tanzim. Can you go to the next slide? Okay, so the second is the current and voltage protection. So of course, there in any electrical circuit there is a two main fault. That is the over current fault, and the second one is the voltage fault, over voltage and under voltage fault. So first is going on to the current protection. In this circuit, this is a over current protection circuit. So what happened in this circuit? And in normal cases like the low current flowing or a low voltage circuit, we use normally fuse. But in case of high or very high level high voltage circuit, so we use relays, breakers, etc. But what happened in this, why we use the fuse? Because we are using this. So, may I continue, sir?
Yes.
Yes, okay, sir. Thank you. So in the low voltage circuit or any low current flow circuit, we use the fuse. What happens in the fuse? When the over current is flow in the circuit, there is a conductor in middle of the fuse, and the conductor is the conductor is burned out, and it is interrupted the circuit, which protect by this, and the fuse protect the circuit. On the next on the next part, that is the diode and the PFT switch, and the diode is used for reverse protection, and the voltage monitor is monitor the voltage. Is it under voltage, over voltage, or is it in the proper voltage? So that is the circuit is about the all current protection. And Tanzim, can you go to the next slide, please? Yeah, that is a over voltage and under voltage protection. In voltage protection, we can use two kind of circuit. One is the fuse circuit, and another one is the Zener diode circuit. So what happens in Zener diode circuit? Zener diode, as we know that there is a breakdown voltage in Zener diode. When there is a under voltage or over, when the voltage is under voltage or over voltage, then the Zener diode break the circuit. And when the circuit is break, then there is no flow of current, and by which the by which this circuit is saved from the damage. And here we are using the resistance. The resistance are the resistances are used for the for voltage dividing. So which will for supplying in the Zener diode. And the second one is the capacitor. The capacitor is used for to reducing the noise that created in the circuit. So Tanzim, can you go to the next slide, please? So here is the thermal management. So these are the basic points about the thermal management. So I like to explain about what is thermal management. What happens in thermal management, like as we can see in a battery any battery like we are using in a mobile or in a car, when we giving a charge or we can plug in in a circuit, then it get temperature or the temperature is getting high over the time. So to manage the temperature, we use as a thermal fuse and thermistor. So the thermal fuse will help to maintain the temperature in the BMS circuit for the battery. And similarly, the thermistor is work as well as the thermal fuse. Tanzim, can you next slide? So this was the cell balancing. Cell balancing, like what happened in a battery. As I mentioned, there are lots of cells like 642,000 cells. So each cell is defined in construction. So what happened in the cell when we get giving the charge or getting discharge the battery, all cells are not uniformly charged or discharged. So what happened when as we can see in the left side, the one cell is almost fully charged. So what will he do? It will share his excess power to the rest of the cell. And similarly similarly in the same as the discharge part. What happened in the discharge part? As we say, the second one is the getting discharged very fast. So the rest of the cells will share their power, share their capacity to the second cell, and does the BMS help to balance the cell. Tanzim, can you go to the next page?
Okay, sir. Through voltage protection. Basically, voltage protection is a protection circuit which protects the battery from over voltage and under voltage. In the voltage protection circuit, two methods are used. One is fuse model, another is Zenodide model. Given circuit, Zenodide model is used. Here are the two Zenodide connected in the circuit. One is for low limit, and another is high limit. So there is the capacitor which is connected into the circuit for cancelling the noise in the device. Or the transistor, which is NPN transistor, is working as a switch in the circuit. So the resistance which are connected in the circuit are calculating the low limit and high limit voltage using the voltage divider rule, which shown in this figure. Next circuit, please. So next slide is thermal management. The thermal management system is very important for battery to protect cells from excessive temperature. Here is a device which is called as thermal fuse. Thermal fuse shut down a battery permanently when is called as thermistor. It also protects the cells from excessive temperature. The thermistor is a temperature sensitive device or a resistor which electrical resistance change in body temperature. So the
Okay, carry on.
the thermistor is two types, PTC or NTC. PTC is the positive temperature coefficient and NCT is the negative temperature coefficient. So basically we use the NTC for our home and other uses. the range of the temperature of a thermistor is minus 10 degrees Celsius to 100 degrees Celsius. In BMS, the thermistor are used to disconnect the battery from the charger in a over temperature condition when the temperature at a point freeze. Then the next slide is next slide is intelligent cell balancing. So in BMS, cell balancing will also play a major role in case of protecting the battery cell. So it is a technique that improves capacity of a battery pack in a battery system. Okay. A battery balancer is an electrical device in battery pack that performs battery balancing. And basically, these balancers are often found in the lithium battery pack for laptop, computer, or electrical device, etc. This balancing can be active or passive. In passive balancing, energy also draws from the most charged cell, disappear and then disappear in heat. Okay. And in active balancing, energy is drawn from the most charged cell and for the least charged cell. There is two figure which is shown the battery balancing system in a charging or in a discharging system. So, that's it. Next slide, which is SOP determination, will be presented by Tanji Mohammed, sir.
Okay. Okay, thank you.
Thank you, sir.
Okay.
Good morning, respected teachers and all my dear friends. As my fellow mate Murray already told about few points why BMS is needed in the current generation. So now I'm going to explain a very important topic, that is state of charge determination. State of charge.
Share your screen, Sanjeev. Your screen is not shared. Again, share it.
Yes, sir. So can you see now?
Ma'am, can you see it? No, no?
Yes.
Yes.
Okay.
Yes.
Just enlarge this one. Okay.
It's okay, sir, now?
Yes, it is okay.
As I was saying, my topic is state of charge. State of charge, in simple words, is the amount of charge left in a battery after continuous use in an application, where 0% stands for empty and 100% stands for full charge, and which is alternately also can be said as DOD. It means depth of discharge. It is the inverse of SOC and we calculated by the discharging capacity, that is 100% means full and 100% means total empty and 0% means full. So basically SOC determination can be done in many ways, but we have here confined it into two modes, that is offline and online mode. In offline mode, we can see Coulomb counting. Coulomb counting is also known as current integration method because it is the simplest of all. This simply calculates the SOC by measuring the battery current and integrating it in time. It's yet so easy, but it is still not preferable because it works only when the battery is at either 0% or 100%. In between, say it is 50%, 60%, the Coulomb counting is not done. So this is a fault in this system, hence we don't prefer it. So moving on to the online mode, the first comes chemical method. This method works only with batteries that have liquid electrolyte in them, such as a lead acid battery. So it is not so common in every battery. That's why chemical method is also not preferred. So we move on to the next method, that is voltage method. This voltage method simply converts the reading of the battery voltage to SOC. However, still we don't prefer it because it has a drawback that it easily gets affected by the temperature. A rise in temperature easily affects the battery, hence voltage method is also not preferable. So So the next is Kalman filtering. Out of all these, Kalman filter is the most preferable because Kalman filter uses a method of difference counting. That is, it takes into account many value for giving us the final value. So Kalman filter is for now is accepted as the best way of getting a perfect value, because in battery management, value accuracy of the value is the most important. So if you can get a perfect value from Kalman filter, we are using it. Then the last one is pressure method. In pressure method, this method is only can be seen in nickel metal hydride batteries, because in those batteries the internal pressure rapidly increases when the battery is charged. So by measuring the particular pressure, we can say what's the status of the charge of that battery. So it is also very rare, so we don't use the pressure method. So in SOC, we can say that the Kalman filter is the best method. So moving on to my next slide, the topic state of health. As it is said, state of health is simply the measurement of the health of the battery. It does not have any perfect way to calculate it. Simply, we can calculate it by various methods of a battery. In reality, we can say that SOH has a threshold point. Say that every battery has its own application, and the threshold point is 5%. So when the SOC is getting, when the SOS state of health is getting nearer to the threshold point, the application, then the battery management system informs the application that your battery is getting old or it is going below the SOH. So it is no more compatible for the battery. At that time, the user can immediately change the battery. So this is a simple use of SOH. So in the next slide, I'm going to say a few things, a few ways how we can measure. So so here are a few ways such as internal resistance, conductance, voltage, capacity, self-discharge, age of the battery, ability to accept a charge, temperature of battery during its previous uses. Here, all the methods are not, they do not have any particular ways of calculating. Say for temperature, if a battery is say we can use a mobile application in 20 degrees centigrade the first 1 year, but in the second year we are not able to use it in the 20 degrees centigrade. It gets heated up. So we can know simply that the health of the battery is degrading, as well as the age of the battery. Say for example, it takes us 2 hours to charge the battery full, but now after 2 years we can see that it takes 4 hours to complete the 100%. So it is a simple knowledge that our battery health is draining. So these are, so state of health can be observed, and we can also see that in this way can say whether our battery is in perfect condition or it is degrading. So now, after we have studied all the ways of why we can use BMS and what are the reasons we are using it, so we try to simulate it in Matlab so that we can get more knowledge. So now, as we have discussed, so now we will use a Matlab simulating to create a BMS for a battery. As everyone can see, we have created an entire model of BMS, and all the functional blocks of the BMS are implemented in simulating toolbox of Matlab. So in the diagram, we can see few blocks that will help us to make a battery management system. They are battery input parameters, NNC neural network control block, FLC physiological control, data storage read-write block, statistical model, and output model. So basically, we'll be trying to see how state of charge can we get, so, and how the temperature works, what is the perfect temperature battery can reside in, and NNC and FLC, that is neural network controller and physiological controller, together will give us the SOC, whereas SOS determination can be done by the statistical model. So in the next slide, here are our few objectives. As I already told, SOC, we have to determine SOC, SOH, and also the current time graph. So as we can see, the input parameter of the NNC, that is neural network controller. Here we have simply taken 5 parameters, that is consumption time, current drawn, terminal voltage, temperature, internal resistance. These all values, the values that we implemented here are real-time values that they have been already experimented, and from various research paper we have collected the values so that we can get a confined battery management system. So these 5 values are being implemented in neural network controller with the help of a multiplexer. As we know, multiplexer help us to confine the 5 values into a single desirable value, and with the help of the multiplexer we have sent the value into the neural network controller. So in the next slide is a subsystem of a neural network controller. Here we can see that the neural network controller, the inputs of there are 3 layers. The neural network controller is a cascade of 3 layers, which are directly connected to 3 dot product block. These dot product block are made up of dot product function. These are predefined blocks where dot product functions are directly calculated. The 5 parameters are directly feed through this port. And after going from the dot product, there are 3 blocks named as net sum. This net sum takes input function of the block and predicts the output function of the 3 layers respectively in a desirable mode. Then going to the next 3 blocks, that are log-seq, log-seq1 and purelin. Log-seq1 and log-seq are 2 log-sigmoid transfer function block, and block purelin is representing a linear transfer function block. These blocks are transfer function that is help us to calculate the required output of each layer from their required input. Then at the last we have 3 blocks. Name is I have named it as go-to, go-to-1, and go-to-1 and go-to-2. Go-to-1 and go-to are simple constants that we get from log-seq1 and log-seq, whereas our most important value is the go-to-2, because here from the purelin we get the specific gravity. And there are 3 more blocks, as you can see in early, that is B4, B5 and B6, that are said as bias values. That means that these are some predefined values that are used to compare the input values that we have given, so that it compares the value and see whether these are desirable values for the purpose I am using it. So this is a work of a neural network controller. So moving to my next slide is implementation of fuzzy logic controller. Here, fuzzy logic controller, first we can see that there are 2 parameters. The first parameter is the specific gravity that we just got from the neural network controller, and the other is the temperature. So these two, fuzzy logic controller mainly uses specific gravity and temperature to calculate the SOC. Similarly, we here multiplexer. The 2 values are being combined and into a desirable value into fuzzy logic controller, and we get the output. Here we have used a fuzzy logic controller because here the fuzzy logic controller takes in analog input and gives out a desirable digital output, say in the form of 0 and 1. So basically our motto of using fuzzy logic controller, because it is said that it always gives a accurate result, and it has an inbuilt function where it works according to the program that we give, whether the values that we are giving is it desirable for the function we are working on. So this is the main work of the fuzzy logic controller, and within the fuzzy logic controller, both defusification and fusification works are going on simultaneously. Defusification simply takes the analog value and give it into a crisp value, whereas fusification, the opposite occurs, and these two together give us a desirable value for the output in SOC. So in the next slide, here is the diagram of statistical model. Statistical model is simply a mathematical model where the entire setup consists of subtract blocks, addition blocks, product blocks, divide block. Here it is a predefined block where the work is already inbuilt to only give the value here. They will be doing the subtraction, addition, and production, multiplication, and we'll be getting the desired result of state of health. So in the next slide, we can see implementation of the workspace. Here, workspace is a block where there are predefined values given to us. This workspace, from this workspace, the value is given to data store, where the data store, as you can see in the earlier slide, the data store then gives the value to the statistical model in the form of DMARC. That is, a single value is being scattered, is being divided properly, and all the networks get it. So here we can see that, here also we can say that the value of the discharge current that we initially took in a neural network controller is also added to the statistical model, so that so that it can perform well. And also, as we can see, these blocks, as I mentioned, that has their own predefined function. These blocks also even help us to calculate a slope. If we want to calculate the slope, we can also calculate it from all the mathematical products that is within the statistical model. So finally, using the statistical model, we can get the SOH that we desire. So the next slide. So after doing all this, the most important part is battery, because if we don't know the behavior of our battery, we cannot make a battery management system. So to study the behavior of a battery, we are converting the entire battery into a circuit, equivalent circuit, so that we can use its value and plot graph. And after studying its behavior, then only our battery management system structure can be worked upon. So the next slide, that is the battery, that is the circuit of the battery, and how the graph will be plotted will be explained by my fellow mate Arendra Deka. Thank you.
Tanzim, can you move the circuit, slide? Thank you, Tanzim, for letting me explain the rest of the slide. And am I audible to everyone? Hello?
Audible. Yes, you were audible. Continue.
Okay. Okay. As Tanzim and my fellow all members explain about the BMS circuit theory and simulation, here is our next slide. So I think everyone is curious about this circuit, why we use this, or what is this circuit is about. So let me explain everything. And as we are going to construct a battery management system, so the main purpose of the battery management system to is to protect the battery, or for a better efficiency. So the the most important part of the battery management system is the battery. So so we have to know about the battery's defined behavior. So they are temperature, current, voltage, charging, discharging, and all. So here we are using the RC circuit. So why we use it RC circuit? So from studies, as we getting to know that this RC circuit is totally called as the equivalent general equivalent mode of electrochemical cell. So why we use this? Because as we have to calculate the equivalent electrochemical cell behavior, we have to calculate lots of things, like it's a very long process. So avoid the long process, we have to use in a simple way, and that is the RC circuit. So in the left side in the circuit, we can see that there are numerous capacitor and resistance value. But for simplification, we will use only one part of the only one capacitor and one resistance for our project. So as the capacitor and resistance is variable, so we need a experimental value, and the circuit is the experimental value is fitted well. So we take the experimental value for a resistor and capacitor from a reliable sources. So after putting this value in the capacitor and capacitor and resistance, we get the different types of graph, like temperature, time, state of charge, and time, and voltage, current with respect to time. So the next slide will be explain all about the graph. So Tanzim, can you go to the next slide, please? No. Okay, this is the first graph, and that is the temperature time graph. So all the four graphs are discharging curves. So what happened? We are using a 31 31 milliampere 31 ampere hour battery of a temperature range between the 20 to 20.5, and this is the in the first position. When the battery temperature rises, it's for the charging. Then when it get discharged, it getting low, it's not about the discharging, it's because the we load the battery is used by the load. That's why the value is deep down. Then when the battery and temperature is rises again, then it going up again. So this is the graph is about temperature with variation in time. Sanjim, can you go to the next, please? So SOC time graph. If the SOC, that is the state of charge time graph, is related to the previous graph, that is the temperature time graph. What happened? According to the studies, we getting to know that the as the increasing of temperature, the state of charge also increasing. As the decreasing of temperature, the state of charge also decreasing. And as we can see in the first that the state of charge is temperature is increased in the charging. So that's why the state of charge is getting charged when we charging the battery. That is 0.8 to 1. Then when it gets discharged, it gets low, and very low, and at last it gets in 0. So this is the graph is about the state of charge and the time graph. Nazim, next please. And this is the graph is the voltage time graph, and this graph and the current time graph, this both are related. And what happens when the first is getting charged, then the voltage is rise. But when it get when the charge is left, or when it get discharged, then it gets slowly, and the deep down part, the in the middle of it, it means that the battery is used by the loads. Or Sanjim, next please. So the from the previous slide, that the voltage time graph is similar as the current time graph, because as we can see that in the first plot, the graph is 0 to 3. That is the time where the battery gets charged. Then when we use the battery, then it get discharged, then it get a value in a 0, or that doesn't we can see the value is uniform. But what happens in defined batteries, in the value can be defined, and the rest of the graph also be in defined session. So Sanjim, can you next? So these were all the graph about the batteries behavior. So now as we are here to almost our project is going to finish, so that's why what we are analyzing the SOC is a high specific gravity and also increases with temperature. So first off, we have to know that what is specific gravity. So specific gravity is that it is the ratio between the weight of the solution to the weight of an equivalent volume of water at a particular temperature. And now how it is related with the SOC. So when in as a electrochemical cell, there is a electrolyte. So the determining the state of charge, the specific gravity play a major role. So there is a formula in related with the specific gravity, that is the cell open circuit voltage equal specific gravity plus 0.845, and as the increase of the specific gravity, the state of charge also increases. And the second point is explaining this, that is the relation between the state of charge and the specific gravity is not similar due to the effect of increase in temperature. When the temperature is high, there is a variation in this both graph, because temperature plays a vital role in the variation. So and the next point, that is the even at the maximum gravity, maybe the specific gravity of the electrolyte may be maximum, but the SOC may not be 100%, because due to there is capacitance loss and various kind of loss. So its operation varies with the temperature. So then the last one we analyzed that the discharge curve for each temperature was run individually through a estimation task. Sanjim, go to the next page. So yes, so here in the last that the what are the applications of the, the BMS? As we know that the battery is the important part. So of course the BMS is also becoming important part. So whenever we use the battery, so of course we need a BMS. So these are the applications that the BMS used in all kind of lithium-ion batteries, used in almost every electrical vehicle like Tesla, like Tata Motor recently launched a car. So like that. So it is used in most industry that use in solar cell, or even in solar cells, like when in a railway station there are solar cell use, or in a hospital. So there will be a battery management system. So it uses in all kind of electronic like smartphone. Yes, of course it's a simple thing that the all kind of smartphone and laptop and charging light, or any kind of rechargeable battery is using a battery management system. Tanzim, can you go to the next? Hello. Oh, okay. So and last we are here in the conclusion. So after completing the almost the whole project and about the behavior of the battery, then we are finally here to the conclusion. So enter here what we are learn about it. The BMS body was discussed thoroughly, and the details of the BMS, including definition, objective, and the function and topology, were discussed by my fellow members Gyanesh, Sri, Tanzim, and Suraj and Mayuri. Advantages of lithium ion and work zone were discussed. So and the last day state of health, cell balancing, and other basic factors BMS were discussed by Tanzim and Mayuri. And Matlab Simulink done analysis, as Tanzim explained about the simulation in Matlab. So thus we can conclude it. And BMS is a basic need for all battery. And last we can conclude that the BMS is a basic need for all battery related equipments for a better performance and good health. And Tanzim, can you go to next? So yes, and not as we are constructed anything like it doesn't matter in BMS or any kind of circuit device, or we are going anywhere. We are of course facing lots of challenges. So yes, there in constructing a BMS there will be various challenges. So first challenge is the circuit protection is a major challenge during the BMS. Of course, if we can't protect the circuit, then what is the use of the BMS? So of course, there BMS should be protect the whole circuit. So that is the first challenging. And the second was the keeping the battery thermally protected. As we know that when we in a mobile or in a rechargeable battery, when we give the overcharge, then the temperature is getting high. So of course the battery should be the battery temperature should be maintained, because if the temperature is getting rise, then the heat is dissipated, and if the heat is damage the circuit as well as the battery. So then the next is the data accuracy. So as we from the state of charge plays in a main vital role in the data accuracy. What happens? State of charge shows can show everything, and like what is its temperature, what is the charge percentage, so everything. So if it can't play the proper data or the true data, then the user will get the wrong information, and he did not know about the about his device or about the battery. So of course the data accuracy should be proper. Tanzim, go to the next. Tanzim. Okay, so future scope, yes, and these are the point in the future scope. So what we are is, as we are in a developing country, or we are in move forward way in a very modern generation. So we have to focus on reliable sources like solar cell, or in batteries. So what happened? Because the future is not about depending on the fossil fuel. It will be completely electrifying. So that's why we have to focus on the battery management system to manage the battery as well. So now these days the battery management system is much developing due to because of lots of improvement in fast charging
अरे
or in
बाबा
batteries. Yes sir.
बस मुंह सूख जाएगा, ज्यादा मत बोल, कंक्लूड करो.
Okay sir. And Tanzim, next slide. And these are the references we are taking for our help or in our project. And the last then we concluded our project, and this is a quote about the necessity is the mother of invention. It's by Plato. And thank you for all to listening this presentation, and hope you all understand well. And if you have any questions, then you can ask well. We are trying to give the best answers to you.
Okay, okay, then go to slide number 36.
Okay, sir.
If you are inviting questions, then I'm ready. uh,
Okay, sir.
Sorry, slide 35. That state of charge. That slide, state of charge.
Okay, sir.
In this slide,
Yes, sir.
you see that there is a dip down, right?
Yes, sir.
It looks like a staircase, flat, and then there is a dip down. So what does that flat part represent? That flat part represent what? That there is no load given to the from the battery, or what?
No, sir. That means, sir, like as a I'm taking an example. Like if we are using a mobile, okay, there's a constant time where when like 1%, like for 1% to 2%, we take time, na sir. We have for getting discharge. So like this, sir, there is a this part is the constant for that time, sir.
No. Do you mean that this time is for change of application or what?
Sir.
Change of that flat part represents what? Flat part represents that you are not using your mobile, or what?
No, sir. We are using the application, but at that time the curve is not going down. But that means the percentage is same during this time, sir.
What percentage is same? The charge percentage is same.
Yes, sir. Yes, sir. Charge percentage, sir. Like 100% to 99, 98, 97, 90, like that, sir.
Okay. And the deep down portion is what? But you are using the mobile, right? You are using the mobile, but the charge percentage is flat. That the charge it is
Sir?
not showing.
Yes, sir.
Oh, what you say, and I could understand is that you are
Yes, sir.
using the mobile, but that charge percentage is not showing that it is decreasing. Is it?
Sir, yes, sir. The curve is about sir discharging, sir. That's why it's getting down.
No. I could understand that it is a discharging curve, but the flat part of this curve, the
Yes, sir.
flat part of this curve, what does it represent?
Sir, it is a constant time for a constant time, sir. There that means, sir, if we like 100%, 90%, there will take time, na sir. So that time is a constant time, sir.
Okay, from 100% to 99%, it will take time. So in this time, are you using the mobile or you are not using the mobile?
Sir, we can use the device, sir. We can use the load, sir. There's no problem.
Okay. So and
Is the current graph show the current graph? Oh, what it says?
Sir, it shows the first part is the sir, charging part. Hello, sir. Hello.
The discharging at a certain time, at an interval of time, the current is discharging. It means what?
Yes,
The load
sir.
is connected at that time. What
Yes,
are you
sir. The
saying?
load is connected, and sir, yes, sir. Load is connected, sir. Sir. Hello.
Okay. That means these two graphs
Sir.
are connected. This curve.
Sir, all four graphs are connected, sir.
Okay. Now I could understand.
Thank you, sir.
Okay, now you see that your charging current is going above 3, right? Charging current, the
Sir?
first part,
Yes,
it
sir.
is more than 3 ampere. All right.
Yes, sir. Yes, sir.
But you see in the first graph where I asked that is it the accepting capability or delivering capability? So there, who told that it is accepting capability? But there it
Yes.
was only 1 ampere.
Sir. So
Yes.
what happened in a battery sir, that they setting or we program the battery to show the value like we have charged the voltage to like let's say example 12 volt. If we charging the battery to a 12 volt, it in the monitor it will show the 12 volt, but in overall the description it getting more higher as we can see the literature survey, then we can it may be 12.70 or 12.8 that level of sir.
Okay. Okay, and I don't know, that question that your Gina diode has 3 terminal. What is that one? I think slide 19, something like that.
Yes, sir.
I think slide 19 or 17, something like that. Your Gina diode was having 3 terminal.
Okay, sir.
That one. What do you have to say for that?
Tanjim.
This one, slide 20.
Sir, there is a two terminal generator, and the rest one is a reference terminal, sir.
Reference terminal.
Yes, sir. For voltage referencing, sir.
Sure. Okay, and
अरे बाबा रेफरेंस कहाँ से कॉपी पेस्टिंग करने से यही प्रॉब्लम होगा है कि नहीं देयर इज नो रेफरेंस टर्मिनल देयर एक्चुअली द सर्किट इज रॉन्ग
so that will be connected in the anode part or cathode part, that your reference terminal.
Reference terminal.
You could understand my question. What you are telling
Yes, sir.
us,
Sir, I understand. I understand, sir. Which part is either anode or either cathode, sir. I understand, sir. But, sir, for this question, sir, I have no idea about it, sir. Which terminal is connected, sir, cathode or anode?
Okay. And the last question is that can you make a battery management system for me?
Sir?
Can you make a battery management system for me, hardware?
Sir, in a hardware, we can't, sir, because we due to the situation we can't do this, sir. But in a software, we'll try to best, sir.
No. It is a paid job. Suppose it is a paid job. Can you make a battery management system for me?